In this video, we'll be going over a GCSE question. Now let's look at our question. The diagram shows a hexagon ABCDEF. ABEF and CBED are congruent parallelograms where AB is equal to BC, which is equal to x centimeters. P is the point on AF and Q is the point on CD, such that BP and BQ is equal to 10 centimeters. Given that angle ABC is equal to 30 degrees, prove that cos of PBQ is equal to 1 minus 2 minus root 3 over 200 times x squared. So on the right here we have our diagrams and then two triangles that we're going to solve for and get values for so that we can show this equation here. So let's start off with analyzing the information we have for our triangle here for ABC. So we know that the side AB and BC is x centimeters. We know that the angle ABC is equal to 30 degrees. And so from here we have to find the length of AC. Finding the length of AC will give us the length of PQ on the triangle that we have remaining. So to find AC, we can use the cosine rule. So the cosine rule is A squared equals B squared plus C squared minus 2BC cos A. So lowercase a is the side opposite angle A, B and C are the two other sides, and A is the angle opposite side A. So our A squared value is going to be AC squared. So we're trying to find the length of AC, and AC we have as A. So AC squared is equal to, so our remaining two sides, AB and BC, are both x centimeters. So we have x squared plus x squared minus 2 times x times cos of 30. So this is a non-calculated question as well. So you would have been asked to memorize certain values. Now we're going to simplify our equation here. So we get AC squared is equal to 2x squared minus 2x squared times, and our value for cos 30 that we have to memorize is root 3 over 2. So this will be written as so we can cancel out our 2's in 2x squared and our root 3 over 2, and so we get 2x squared minus x squared times root 3. And so this is AC squared. Now, for our second triangle here, so our second triangle PBQ. So we are going to try and show that cos of PBQ is equal to what's given in the question. We know that our length PB and BQ are both 10 centimeters. We don't know our angle PBQ, but we do know the length of PQ. PQ squared will be the same as AC squared. Now, to show that cos of PBQ is equal to what's given in the question, we're going to reuse the cosine rule. However, we're going to rearrange it so that it gives us a value for the angle instead of a side. So you can do this in your own time, but rearranging will give you the value of cos A is equal to B squared plus C squared minus A squared over 2BC. Now, let's substitute our values. So the reason we didn't square root AC is because we're going to square PQ anyways, and since AC squared is equal to PQ squared, there's no point in square rooting it. So let's substitute our values in. Let's see what we get. So we get cos of PBQ. So we're taking PBQ as angle A here, and that's equal to 10 squared plus 10 squared minus, and then we have A squared here, which is whatever AC squared is. So that's 2x squared minus x squared root 3. And now this will be in brackets. So we will have to multiply our negative sign in later. Now, then we divide it by 2 times 10 times 10. So now we're going to simplify our fraction. So we get, so 10 squared is 100. So we get 100 plus 100 minus 2x squared plus root 3 x squared all over 200. Now what we can do is we can factorize the coefficients of x squared that we have here. So we add together 100, so we get 200 minus, and so here if we factorize out our x squared, we get x squared multiplied by 2 minus root 3, because we've taken minus x squared out of both values, and we have this all over 200. Now, since the 200 and the values for x squared are separated by a minus sign, we can split it into two different fractions. So we get is 200 over 200 minus x squared times 2 minus root 3 all over 200. So now we get 1, which is 200 over 200, minus 2 minus root 3 over 200. And since our x squared is the numerator, our fraction has been multiplied by x squared, so we can always bring it down to the side and show that cos of PBQ is equal to 1 minus 2 minus root 3 over 200 times x squared. So, with questions like this, if you find that you can't seem to get towards your answer, you can always work back, or you can simplify further up in your equation that gives you favorable values. As always, thank you for watching, and make sure you subscribe so you don't miss out on any new content.